And now I shall perform for you a 2.5 dinner with a twist. Look at that penguin. What a majestic creature. Okay, we're going to do 18 problems together. Your test will occur during the next class. Look at how cute he is. He looks very excited. So in other words, you need to be copying these problems down as we're going through them in your composition book. If I'm going too fast, pause the video. All right, simplify. On this one, the first question you're really asking yourself is there a square root of 144? If you happen to have memorized those perfect squares I told you to memorize, you would know it is 12. So your answer is plus or minus 12. If you don't know, remember, you're going to do some hedging. And we're hedging. And we're going to take out a pair of 2's, brings out a 2, take out a pair of 2's, brings out a 2, take out a pair of 3's, brings out a 3, 2 times 2 is 4, 4 times 3 is 12. The plus or minus has to be in front. On this one, there's a negative, so I'm going to leave a negative. Is there a square root of 25? It is, because 5 times 5 is 25. Is there a square root of 15? There is, because 4 times 4 is 16. I think I said 15. You know what I meant. You know what I meant. This one, there is no solution. Technically, it is called no real solution because you will learn all about how to do this problem in Algebra 2. Anticipation. Can't have a square root with a negative number under it. Okay, 24 does not have a perfect square, so we are going to hedge. Divide by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. Divided by 3 is 1. Remember, we're looking for pairs. 2 times 2 is 4. The square root of 4 is 2. The 2 and the 3 do not have pairs. Everything outside gets multiplied together and goes outside. Everything inside gets multiplied together and goes inside. So my answer there is 2 square roots of 6. Look at, these are the good penguins. They're paying attention. Look at these two. They're like wandering off into space. Ooh, what's going on over there? Those are much more like my students. All right. This has a 3 outside. We're going to set it up for the hedging or the simplifying of the square root. Is there a square root of 16? There sure is. It is 4. It's a perfect square. So 3 and 4 are both outside. So we would multiply them together to get 12. For this one, we're going to set it up. 4 is outside. Now we're going to set it up for the simplifying to happen. So I'm going to go over here and I'm going to simplify 32 by hedging it. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 1. And I'm looking for pairs. 2 times 2 is 4. The square root of 4 is 2. 2 times 2 is 4. The square root of 4 is 2. So 2 and 2 came out. Everything outside gets multiplied. Everything that didn't make it outside, these guys, they did not have partners. They multiply and stay inside the radical. Once you're outside, everything that's outside is going to get multiplied. 4 times 4 is 16. And the guy inside the radical is going to stay there. So it's 16 times the square root of 2. All right, then remember, with exponents, we need to have the variable to an even number. If that's true, it just comes out as the variable to the even number divided by 2. If we have the variable to an, oops, it's supposed to be next, to an odd number, we're going to rewrite it to an even and 1, and then we're going to bring this out by dividing. So on number 7, when we look, they're both even. So I'm taking a to the 6 divided by 2 and b to the 8 divided by 2. So I get a to the 3rd, b to the 4th. Everybody was even. They were all perfect. They came outside. On this one, I have 4 things. I've got the 36, the x, the y, the z. Even, even, even. That makes me happy, happy, because I can just divide. And 36 is a perfect square. It's the perfect square of 6. I'm going to take 4. Now remember, what I'm doing is I'm dividing by 2. So it would be to the 2nd. For my y, it's got an even. 8 divided by 2 would be to the 4th. And for my z, it's also got an even exponent. So 12 divided by 2, whoops, that's a 2, would be 6. Nothing was left inside. For number 9, the first thing I'm going to look at is that 3. 3 is a prime number. It cannot be simplified. So I'm going to leave the 3 inside. I'm also going to rewrite the x because it is odd. So I'm going to rewrite it as x to the 8th and x to the 1st. I'm going to rewrite the y because it is also odd as y to the 10th and y to the 1st. The square root of 3, there is absolutely nothing I can do with it. It stays inside as 3. The square root of 8, I'm going to take it and I'm going to choose a new color. How about light blue? Divide by 2. So x to the 4th comes outside. X to the 1st stays in. The y to the 10th, I'm going to take it and divide by 2. So it's going to be y to the 5th comes out and the y to the 1st stays in. Remember, everything that's perfect comes outside, everything else stays inside. Okay, oh, look at him. That is just too cute. Hello, hello, little guy. I shall call you Ralph. That looks like a little Ralph, doesn't it? Hi, Ralph. Okay, so these are fractions. Question number 1 is, can you simplify so that you're working with smaller numbers? The answer to number 10 is no. 8 and 7 do not simplify. So we're going to rationalize by multiplying by the square root of the denominator. The reason we do that, remember, is 7 and 7 are both inside, so we can multiply them together and get 49. 8 and 7 are both inside. We're going to multiply them together and get 56. Now I got to find out what the square root of 56 is, so I'm going to hedge it. Divide by 2, I get 28. Divide by 2, I get 14. Divide by 2, I get 7. Divide by 7, I get 1. Out comes a pair of 2s, so 1 2 comes out and a 14 stays inside. The square root of 49, remember we also said if you have the exact same number times itself under the radical, you just bring that number out. Okay, 5 and 3 cannot be reduced because they're both prime. So I'm going to multiply by the, oops, that's supposed to be a 3, not a 0.3. I'm going to multiply by the square root of the denominator. The reason for that, remember, is square root of 3 times square root of 3 is square root of 9, which we all know is 3. Up on the top, these are both inside, so 5 times 3 is 15. I'm going to go down here to Ralph, and I'm going to hedge. Divide by 3, 5. Divide by 5, 1. Absolutely nothing had a partner. Nothing is perfect about 15, so it stays inside the radical. On number 12, the first thing I'm going to do is reduce it. I'm going to simplify. I'm going to divide them both by 5. I'm allowed to do that because they're both under the radical still. So 35 divided by 5 is 7. 15 divided by 5 is 3. The reason I do this, I'm working with smaller numbers. My life's easier. So I have the square root of 7 on top, the square root of 3 on the bottom. In order to rationalize, I multiply by the square root of the denominator. Remember, square root of 3 times square root of 3 is just 3. 7 and 3 are both inside. I get the square root of 21. You go down here to Wreck-It Ralph, and I'm going to hedge 21. Nothing comes outside, so that is my answer. The answers don't look any prettier, but they are rational on the bottom, and that's what matters. Okay, solve using the quadratic formula. I'm going to assume this is equal to 0, and we're going to write down the quadratic formula. Make this big in your notebook. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Woo! Okay, we are going to identify a. A is 1. We are going to identify b. B is negative 12, which makes the opposite of b 12. We are going to identify c. It is 20. We are also going to do the discriminant, b squared minus 4ac. So negative 12 squared minus 4 times 1 times 20. So negative 12 squared is one of those numbers you were supposed to memorize. 12 times 12 is 144. Minus 4 times 1 is 4 times 20. I'm running out of room here. 144 minus 80, because then you do the 4 times 20. Got to go in order, and we get 64. So x is going to equal the opposite of b, which is 12, plus or minus the square root of the value of the discriminant, which is 64, all over 2 times a, which is 1. So we have the 12, we have the plus or minus, 2 times 1 is 2. The question is there a square root of 64? There is. The square root of 64 is equal to 8. Those are the ones you got to memorize, guys. It is not equal to the square root of 8, it's just equal to 8. So since there are no square roots left, we're going to do 12 plus 8 over 2, which is 20 over 2. So we find out x is 10. There's one solution. And we're going to do 12 minus 8 over 2, 12 minus 8 is 4, and 4 over 2 is 2. Remember, when we're doing this, we're finding the solutions, which is the same things as the x-intercepts, zeros, roots. It's where it crosses the x-axis. All right, so this time it equals 12. Oh, look, they're so sad. It equals 12, Mom. We have to bring the 12 over. We do that by subtracting 12. So we have x squared minus 4x minus 12 equals 0. Once it equals 0, we identify a as 1. It's the coefficient of b squared, or of x squared, sorry. B is negative 4, making the opposite of b 4. It's always the coefficient of x. C is the constant, which is negative 12. We're going to do the discriminant, b squared minus 4ac. So it's going to be negative 4 squared minus 4 times 1 times negative 12. So 16, 4 times 1 is 4, times negative 12. Negative 4 times negative 12 is a positive 48. 16 and 48 is 64 again. We like that number. All right, so we're going to go over here. X is going to equal the opposite of b, which is 4, plus or minus the square root of the discriminant, which is 64, all over 2 times a, which is 1. Now, because we just did 64, we know the square root of 64 is 8. So we're going to go to our two answers. X is going to equal 4 plus 8 over 2, 12 over 2. X is going to equal 6. X is going to equal 4 minus 8 over 2, negative 4 over 2. So X is going to equal negative 2. All righty? If you're pausing, pause, but otherwise, let's keep going. Solve using the quadratic formula. We got to bring this 3x squared over. We're going to subtract 3x squared from 4x squared, and we're going to subtract 2x. So when I write it in order, I get x squared minus 2x minus 15 equals 0. Look at, they're taking off. Come on, guys, you can take off and do this problem. What is A? A is 1. What is B? Negative 2. The opposite of B is 2. C is negative 15. So we've got B squared minus 4AC. Negative 2 squared minus 4 times 1 times negative 15. This is 4. 4 times 1 is 4. Then you got to do negative 4 times negative 15. You got to be really careful with those negatives, guys. And that's going to equal, oh my gosh, positive 60. The answer is 64. If you don't know the square root of 64 by the end of this video, you are not paying attention. That's the secret word. What is the square root of 64? 8. All right, so x is going to equal 2 plus or minus the square root of the value of the discriminant, which is 64, all over 2 times 1. 2 plus or minus, we know 64 has a square root of 8. Google one erase. There we go. So I'm out of room, so I'm going to go this way. X is equal to 2 plus 8 all over 2, which is 10 over 2, or 5. X is equal to 2 minus 8 over 2, negative 6 over 2, negative 3. So X is equal to 5, and X is equal to negative 3. All right, here we go. Slide number 10 out of 12. We got to move that 3x over. We're going to do that by subtracting 3x. Look at, he's watching. This is a good student. This student gets an A+. Look at him paying attention. Yep, yep, yep. Then this is that other one going, hey, what are you doing? 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 Doing the quadratic formula, people. A is 1. B is negative 3. Opposite of B is 3. C is negative 10. We are now going to find the value of the discriminant. Ooh, that's hard to see. B squared minus 4AC. Negative 3 minus 4 times 1 times negative 10. 9 minus 4 times, whoa, ho, ho, equals 49, which is not 64. So we go over here. X equals 3, the opposite of B, plus or minus the square root of the discriminant, which is 49, all over 2 times A, which is 1. The question at this next step is there a square root of 49? The answer is yes, it is 7. So X is equal to 3 plus 7 over 2, which is 10 over 2. x equals 5. X is equal to 3 minus 7 over 2, negative 4 over 2. X is equal to negative 2. All right, woohoo! We're almost done, we're almost done. One more after this one. Solve using the quadratic formula. It equals 0. Now guys, pay attention. A is 4. What is B? Remember, B is the coefficient, ax squared plus bx. It's the coefficient of x. I don't have an x, so B is 0. C is the constant, which is negative 49. Let's find the discriminant. B squared minus 4ac. 0 squared minus 4 times negative 49. 0 squared is 0. 4 times 4 is 16 times negative 49. So I need to do negative 16 times negative 49, and it is 784. Whoa, it's a little bigger than 64. So x is equal to the opposite of b, which is 0, plus or minus the square root of 784. All over 2 times a. I'm going to go to my calculator and I'm going to see if there is a square root of 784. There is. Now why did I do that? Because it's a big number. And anytime it's a big number, try it. It comes out to 28. If it didn't come out to a perfect square root on my calculator, I would have hedged it, okay? So I have 0 plus 28 all over 8. So 28 over 8 is going to simplify. Let's see, I can divide them both by 4. I'll get 7 over 2. And I can take 0 minus 28 over 8. So I get negative 28 over 8, which is negative 7 over 2. All right, last slide. X squared equals 25. I'm going to bring the 25 over by subtracting. So I get x squared minus 25 equals 0. A is 1. We have no x squared, so it's 0, making the opposite of b 0. C is negative 25. When I do b squared minus 4ac, I have 0 squared minus 4 times 1 times negative 25. 0 minus 4 times negative 25 is 100. So x is going to equal the opposite of b, which is 0, plus or minus the square root of the value of the discriminant, which is 100, all over 2 times a, which is 1. Is there a square root of 100? It is 10. That's one of them you were supposed to memorize. So x is equal to 0 plus 10 over 2, which is positive 10 over 2. X is 5. X is going to equal 0 minus 10 over 2, which is negative 10 over 2. Which is negative 5. Do they all come out that nice? No. Maybe we'll try some of those before we have our quiz in class next time. But come to class with all these 18. Remember the secret word. Look at this, guys. Woohoo! Celebrate, party with him. Yeah.